Good morning, all, to this lecture, the theory and practice of design computing tool, Act 822. We'll be dealing with using BIM in integrated project delivery. And we're looking at scheduling and 4D simulation. It is important that we understand that project managers can create a 4D simulation of the plan construction process by linking elements in the composite model to a timeline of project tasks. And for the simulation can have many construction process planning applications. For example, validating the planned sequence, construction operations, and identifying any time-based clashes. You know, when we talk about composite model here in this course, we need to understand that for what we will be doing this semester, we'll be using a BIM software called Navisworks Manage. Navisworks Manage. Navisworks Manage is an Autodesk product and is basically used by architects for project management and also for identifying clashes on a project. So under this environment, the architect's model, the structural engineering model, the mechanical and electrical engineering model are brought together in the same environment under Navisworks Manage, and they are combined together to form the composite model. This composite model contains the architect's model, the structural engineer's model, the mechanical engineering model, and the electrical engineering model. They are fused together. And then that composite model can be subjected to a lot of queries, and it can be used for the simulation of the project. You know, in creating a 4D simulation for a project, you do that by linking timelines of project tasks to model elements. And we can create a complete 4D simulation of the construction process from the demolition phase through owner moving. And this simulation can be used to inform critical planning decisions. So this simulation can be used to inform critical planning decisions about construction methods, resource allocation, activity sequencing, site space utilization, and so on. And we need to understand that when you're handling large-scale construction practice, there are so many things that are involved. So many things that are involved that ordinarily, if we are using our traditional methods for project planning, it will be very, very difficult and tedious for you to be able to complete that task in a record time. We need to understand that what brought about all this suite of software that we're using is because of there's a need for better performance. There's a need for us to build better, build smarter, build faster, and build cheaper. So this suite of software is what is going to help us to situate all these concepts in a project delivery environment. With these tools, it will be easy for us to know how to allocate our resources on the project. And with these tools, we should be able to see how our construction methodology, how it impacts on the projects, on the time to complete the project, the cost of the project, and a lot of other things that we cannot be able to envisage from the beginning. Even in our site space utilization, it's important that once you create it or your 4D simulation, you should be able to know how to manage your site. Let me give you an example now. When you talk about resource allocation on a project, you need to understand that if you're handling a large-scale project, maybe you begin with piling. Once you're done with the piling, then the contractor goes ahead and starts his pile caps. And when they're done with the pile caps, then the actual foundation on top of the pile caps, and at the end of the day, the floor slab, the ground floor slab, and then every other thing proceeds from there. But in terms of resource allocation, if you have a 4D simulation, you should be able to know at what point do I expect to have this particular material? At what point do I expect to have this equipment on my site? Now, relate it with site space utilization. If you are given a project site and you want to start a project, you should be able to have a sequence, a simulation that tells every other person that is, every other stakeholder on that project, for them to see, this is the space that you have, this is the size of your building, and this is the space that you have around that building footprint to be able to plan everything that you're planning on that site, your site office, your site yard, where you keep your equipment, where you fabricate all the other building elements and components that you're going to use on that project. With this, it will be easy for anybody that watches that simulation to be able to understand in details what you are planning to do on that particular project. Now, what we typically do using Navisource Manage Timeliner tools enablers by the project teams. Now, we can manually enter information about project tasks. What it simply means that under Navisource Manage, under Timeliner tools, because you know that once you bring in your models, once you bring in the architect's model, you bring in the structural engineer's model, you bring in the mechanical engineer's model, you bring in the electrical engineer's model, in the same environment, it becomes the composite model. That is the database that contains every single information that has to do with that particular design. All systems, all methods, all materials, everything that has to do with that project is embedded in that model. And then you can be able to extract information from that model and you can be able to use the model to create a 4D simulation. Because once you bring in that model consists of elements. Consists of, for example, maybe your piles. It consists of your reinforcements. It consists of your walls. It consists of your floors, your windows, your doors, your roof, your site's components, everything that is supposed to be on that project. You can access them through your Timeliner tools. And when you access them through your Timeliner tools, you can be able to apportion time. You know, you're trying to create a 4D simulation of your project, which means in your Timeliner tools, maybe the very first one you need to select is the piles. Depends on the type of piles now. For example, there are two different types of piling equipment that is available now. There's a particular one that makes so much noise as they are pounding on the ground, creates so much noise. on the site and in the neighboring environment. And then there's a particular one that's like, it's like a rig that crawls through the ground and doesn't make noise. And that is the one that is most preferred. I can't remember the exact name. When I remember the name, I'll tell us. And then in your timeliner too, you should be able to know, okay, this is my pie. This is the particular one that I will use. And once you indicate that particular one that you use, you should be able to bring in the model of that particular piling equipment under your site. And you should be able to use your coordinates, because on a building site, once you want to start your piling, there's something that they call coordinates. So a surveyor should be able to give the coordinates of each of the piles that will be on that particular project. And once he has done that, and you as an architect, you have access to that information, then you should be able to indicate that your piling machine that is on that particular place, where and where and where and where and where under your site is supposed to place those piles, and then the size of those piles. I'm just giving you a typical example of piling now. And now, once you are done with that, then the next thing is the pile cap. Remember, pile cap as an element on your project, you can easily identify it, and it's a structural engineering element. So with that, you can be able to now go to your timeline and after selecting your the piles, then the next thing that you need to select is the pile caps. And you see, as you're doing this thing now, you are adding information to the timeliner tools. As you're adding information to that timeliner tools, you have indicated that the first one that should go is the piles and the machine, and the next one is the pile cap. And as you are indicating your pile cap, you should also be able to indicate how will this pile cap be placed. What is the construction method that you're going to use to place this pile cap? Now, in your timeliner tools, you indicate all these informations. And once you indicate all this information and you build it gradually, because you as an architect, you should know that after when you want to start a building project, for example, you have a site. The first thing that you need to do is, first of all, the site will be cleared. When the site is cleared, then the site will be leveled, and all things that are on that side that will be an encumbrance to the project will be removed or moved to the side. Then the next thing is your piles, depending on the size and scale of the project. Then after the piles, the pile cap. Then after the pile cap, then the standard foundation, the way we know it. And then from the foundation, your foundation walls. And then after your foundation walls, then you fill to make up levels in terms of your hardcore and filling with laterite to make up levels. Then you cast your ground floor. Then after casting your ground floor, depending on the building that you're working on, then the next thing that you need to do first is your reinforcement, your starter bars. Your reinforcement are built up. After they are built up, then the next thing is the formwork. Then the next thing is they are casted. And then the next thing is the slab comes in. The formwork for the slab comes in. And then the ironwork for the slab comes in. And then the concrete comes in. So in your timeliner tools, you as an architect, you know exactly what follows the other one. So you should be able to manually enter information one by one. And as you do that, this information is populated. And at the end of the day, you can now animate it because it is a timeliner tool. And that is how you can now be able to see a 4D simulation of a project that you're working on. There's a video of a typical example of what I'm just discussing. If we have time, I should be able to play it. If not, maybe in our next class, you should be able to show it to us. Now, it's also possible that you'll be able to import project schedules from a wide variety of project planning tools. What am I trying to say here now? If you have Microsoft projects and you already have a project plan that you did on Microsoft project, your schedule that you did on Microsoft project, where all the timelines for each element in the building are clearly defined. You place it just like I was trying to explain earlier. Your pies, your pie cap, your foundation, making up labels, your hardcore, your mass concrete floor, your reinforcement starters, your formwork, your cast, then the slab. Then you proceed. Now, once you're able to do that on Microsoft Project and a lot of other project planning tools, you can bring that your Microsoft Project file into Navisworks Manage, and it's be able to link the elements in the composite model with tasks in your schedule. Get it? Too? You should be able to link the elements in the composite model with tasks in your schedule. For example, you already have piling as a task in your schedule. And then in your structural model, there is piles that's already there. So once you bring in the file, the file that contains that schedule, you can link each of these elements in the composite model. For example, your piles, your pile cap, your foundation, your making up levels, your mass concrete floor, your reinforcement starters, your formwork, then the casting, and then every other thing that is sequentially arranged in that your project schedule. You can, and you know, everything that is sequentially scheduled in that project schedule that you have is a particular element in that project. It's a particular element. So you go to your model, your composite model, that element is there. So what you're expected to do is you link that element with that task in the schedule. And then once you are able to do that, you should be able to simulate the schedule and see the effects on the model. You know, and as you are doing that, you need to look at it from the perspective of, okay, this is the plan. This is the plan that you have planned your schedule versus the actual thing that is supposed to be happening there. And then once you are done with it, you should be able to export images and animations that are generated from that exercise. That is based on the results of the simulation. Meaning that two things that we've just discussed here in creating a 4D simulation, a 4D sequencing. Some people call it 4D simulation, some people call it construction sequencing. So once you're able to have that Navisworks Manage with the timeliner tools, you should be able to go ahead and assign the material, the elements on your project to a particular task. That is doing it manually. You can also import your schedules and then link it with the elements in your composite model. And then you should be able to simulate it. At the end of the day, you have an animation that can be shared among the project team members. And now, if you look at our slide here, so that our timeliner, it automatically updates the simulation of, if the model or schedule changes, and offers many options for creating customized simulations to support the need of the project team. You know, most of the times when you tell people things, if you are trying to tell a story with words, it will not be the same as when you are telling a story with pictures or with videos. So in a project team, in an integrated project delivery, you know, when we talk about integrated project delivery, IPD. We're talking about being able to manage a project by all the, trades or disciplines in the AEC industry coming together as a single project team. For example, to be able to have an architect, be able to have a structural engineer, to be able to have electrical engineer, mechanical engineer, a quantity surveyor, possibly the client, possibly the user, and possibly the financials or any other item of work that involve the specialists. So once you have that team, then you can now say that you have an integrated project team. And in an integrated project delivery meetings, these are some of the things that are discussed there. Looking at schedules, looking at your the time allocated for each task on the project. And that kind of an environment, the teams can look closely at the information or data that is available to them and make what is called an informed decisions. This is a departure from the traditional method of handling projects. As a matter of fact, in the current best practices globally, there is a thin line between design and construction, which means when you have a large-scale project, these two components of the in the design and construction industry, they are seamlessly fused together, because we need to understand that cost is an important aspect of what we should be looking at. Time also is an important aspect of what we should be looking at. So this environment, the Navisworks environment, it gives the project team an opportunity. It gives the project team an opportunity to seamlessly transit from concept development, design documentation, construction documentation, and actually the construction itself on site. This becomes necessary because in a traditional process, so many things takes place. Times are lost because when you're working on a large-scale project, human beings being what they are, there's nobody that can say that he's 100% accurate in anything that he's trying to bring on the project. So under that environment, with the help of design technology, there are so many things that can be looked at that ordinarily, using the traditional process of design, it might be impossible for you to be able to situate all those things on the project. And what it simply means that once those things are identified ahead of time, decisions are made on what is supposed to be done. And when those decisions are made, what it simply means that we've been able to, save time. Because if the project is already running and these things are discovered in the course of the project, it simply means that there is a cost that is associated with that particular thing that was not captured from the beginning. And even trying to do it at that point in time, it requires a lot of things. It requires being able to, first of all, stop the project and possibly remove some elements that has already been installed, or to make changes or corrections. That takes time, that takes money, and it is not always palatable to clients. So in an integrated project delivery environment, these things are situated, these things are profiled, these things are queried ahead of time. Because when you have that composite model, it gives you an opportunity to look at what the architects have done. It gives you an opportunity to look at what the structural engineers have done. It gives you an opportunity to look at what the mechanical and electrical engineers have already done. In a composite environment, these things can be queried. If there are anywhere they are having clashes, these things can be sorted out, and that is before you hit the ground. And it makes it easy for you to make corrections. You can easily make corrections on the paper. it will only cost you a few dimes to get another paper. But when you have started a project and billions has been committed on that project, and as you are going, you now discover that there are some things that you overlooked, or there was some oversight, and that you need to go back to correct those things. It has a lot to do with the time schedule for the project is altered. The cost of that project is altered. And it's not always palatable. So that's why we need to situate our project under this environment to be able to check a lot of things. You use these tools for clash detection. So when these models are brought into one environment, they can be able to subject them to different kinds of queries. You can be able to check architectural versus structural. Then you will now begin to see where there are clashes. And where there are clashes, you start red flagging it ahead of time. You'll be able to profile the architectural versus mechanical, profile the architectural versus electrical, and even structural versus mechanical and electrical versus mechanical. All those things can be profiled with a composite model in this environment for you to be able to see where you might need to make changes before you now hit the ground. Now, like I'm saying that your timeliner automatically updates the simulation if the model or schedule changes. And it offers many options for creating customized simulations to support the needs of the project team. Now, before linking the composite model to schedule tasks, it is important to group model elements. What do I mean? You know the model elements that are supposed to be constructed together. So once you group it together, it is easy for you to create simulations. And also create search sets that facilitate easy mapping. And then when we get to the point of a hands-on task, you should be able to understand the importance, and you should be able to demonstrate it so that you understand it very well. Okay. I think for now, for the sequencing and scheduling, I think we should stop here. At the next class, we should be able to deal in details with time-based clash detection on our projects. So at this point, please, I would like to take your questions or your comments. You can put them on the chat box, or you can raise your hand and I will unmute you so that we can make your comments. Still waiting for you, your comments. Please note that this afternoon we'll have another Zoom class. This one will be on our design. We'll have another Zoom class this afternoon by 2 p.m. That will be on our design. So on that class, we should be expecting you to share your work with us, to share your screens, to show us what you have been doing, what you have done thus far. and the design skill that you're working on for this semester. So just have less than a minute. You guys didn't log in on time. So in the absence of any other question, we'll end the class here. Hoping to see you again by 2 p.m. this afternoon for design.